X equals 4 when y equals 12. If x equals 36, find y if A, the variables vary directly, B, the variables vary inversely. In direct variation, it's x over y equals x over y. Okay? Inverse, it's x over x with subscripts 1 and 2, and then y over y with the subscripts 2 and 1. Okay? So, direct variation, you just put the 4 over the 12, and then 36, and we don't know what y is. We know 12 times 36 equals 4 times y, okay? So 108. Okay, now inversely, well, you got to go up and put subscripts on the values. So this is x1, y1, this is x2, y2. So x1 over x2, so it's going to be 4 over 36, y2 over y1. So y2 we don't have, so that'll stay y2 over 12. Then 4 times 12 is equal to y times 36. So I take 4 times 12, get that product 48. That's equal to 36 times y. So I divide by 36. Second PRB, that's 1 1/3. So y2 equals 1 1/3. And now we get into some crappy stuff. Graph the equation y equals 2 over the quantity x plus 3, and then after the fraction's over we have plus 4. That plus 4 at the end is known as a k value. So this is a rational function because the independent variable x is on the bottom. So with rational functions we need to get our asymptotes down. We need to know our horizontal asymptote, our vertical asymptote, and the hole, any holes in the graph. Now the horizontal asymptote, it's kind of weird, but you have to remember it, okay? You're going to go y equals, horizontal is expressed as y equals, and you're just going to put your 2 over your x. You're going to forget about the plus 3. Now, x is on the bottom, so as x gets bigger, like 200,000, 2 divided by 200,000 is really close to 0, okay? So y equals 0, but, and you can't forget this, but if there's a k value, you need to perform that operation to your y. So y equals 4, okay? 2 over x, x is on bottom, so it'd be 0 if that plus 4 wasn't there, but it is there, so it's 4. So on the y-axis, I go 1, 2, 3, 4. I make a horizontal line, titling it y equals 4. Now the vertical asymptotes, you see if you have to factor on the top or the bottom, well 2 is one term, it can't be factored. X plus 3 is 2 terms, but look at it. You think you could go GCF DOPS with that? Well, the GCF would just be 1, so no. And it's definitely not a difference of perfect squares. It's not even a difference, it's a sum, okay? So, not doing anything with that, so that will just stay the same. Put it in parentheses, though. And you need to keep the plus 4. Okay, now, vertical asymptote. Now that you couldn't factor that expression, x plus 3, you set the denominator, whatever in the denominator on bottom, equal to 0. You subtract 3 from both sides, and you get negative 3. Now, does that stay a vertical asymptote, or does it go to a hole? Well, I can't cross out the x plus 3 because I don't have that expression on top, so that stays on as a vertical asymptote, and there are none for holes. So you go to negative 3, 1, 2, 3 on the x-axis, and that's a vertical. X equals negative 3. Now you're set to do your graphing, okay? You only have one vertical asymptote, just one, so it's just left and right. So I pick 2 coordinates on each side, x, y, x, y. Okay, so left and right of what? Well, the x equals negative 3. So 2 points to the left of x equals negative 3 are negative 4, negative 5. 2 points to the right would be negative 2, negative 1. Now, you put y equals, and you're going to put negative 4 in for x. Now, you know you have this 2 on top. Now, let's figure out what is going to happen on bottom when I put negative 4 plus 3. That's negative 1. Now, you got to remember there's a plus 4 there, though. Okay? So we're going to go 2 divided by negative 1 plus 4, and that gives me 2. Okay? Now I put the negative 5 in for the x. So y equals, you know you have a 2 across the top of your fraction. Now you're going to substitute negative 5 in for x. Okay? So negative 5 plus 3 is negative 2. But you will have to add the 4 after you divide. So 2 divided by negative 2 plus 4 is 3. So I plot those. So negative 4, 2, 1, 2, 3, 4, 1, 2. Negative 5, 3, 1, 2, 3, 4, 5, 1, 2, 3. Okay? Okay, and that just goes against the horizontal vertical asymptotes. Now, right. So put negative 2 in for x down here. So you have the 2 across the top. Now, we need to put negative 2 in for x, negative 2 plus 3. That's 1. And then plus 4. Well, 2 divided by 1 is 2. I put y equals in front of it. Plus 4 is 6. Now I'm substituting negative 1 in. Okay? Negative 1 plus 3 is 2. And after the division takes place, we have a 4 to add. So 2 divided by 2 is 1. Plus 4 is going to be 5. Okay? So negative 2, 6. 1, 2, 3, 4, 5, 6. And negative 1, 5. 1, 2, 3, 4, 5. And that's your other part of the graph. Okay? Now that's done. Okay, number 3 and 4. For each rational function, identify the holes, the horizontal asymptotes, and the vertical asymptotes. So, I would do the horizontal asymptote first, then the vertical asymptote, and then the holes. Natural line of progression, okay? Now, again, y equals, you set your x over your x, okay? You don't worry about anything else on the fraction. There's nothing, no k value added behind it, okay? So, x over x. Now, here we simplify. Now, I'm not going to have you're like it's on top and bottom. Well, that's why you got to cancel, okay? They're both to the same power, so you cross them both out, and then that's 1. When you get a straight cancellation, it's 1. And no, I don't add or subtract to 1 because there's nothing behind the fraction. There's no k value, okay? Now, the vertical asymptote, you got to see if you can factor. That's 2 terms up here and 2 terms down here. So x minus 5, that's 2 terms, so GCF DOPS. If you know that it can't be factored, you might as well just write it down. I'm just showing people who need that step-by-step analysis. So 1's GCF, and it's minus, take the 1 off the front. X isn't to the second, so it can't be a DOPS. So that is a prime expression. It will just stay. And x plus 3 is the same thing, okay? Now you take the denominator, the bottom, x plus 3, set that equal to 0. So you subtract 3, and you get negative 3. So does that stay a vertical asymptote, or does it become a hole? Well, I have x, that x plus 3 cannot be canceled because I don't have it on top. So it stays as a vertical asymptote, and the hole is none. Okay, number 4. Horizontal asymptote, vertical asymptote, holes. Okay, so horizontal, same thing. You put y equals, you look at the first term on the top of each fraction. You have x over x to the second. Now you have x on top and bottom, so you want to cancel where the smaller one's at. You have x to the first, so it's going to be 1 over x to the first power, okay? So you have an x, it's on the bottom, so if it's on the bottom, as x gets higher, the y gets smaller, so then it's 0, okay? So if x is on the bottom, your y asymptote is 0. Now there's no k value, so 0 is what we stay with. Okay, now the vertical asymptote, you need to see if you can factor. That's 2 terms, x plus 5, and that's 3 terms. The 3 terms can definitely be factored, the 2 terms not so much. So GCF and DOPS. GCF's 1, it's not a DOPS, so that will just stay the same, x plus 5. Now at bottom, that trinomial, we need to see if we can factor that. X second plus 2x minus 15. So 3 terms, so it'll be GCF and T-table. 1's your GCF. ABC, 1 times negative 15 is negative 15. So that is a mismatch of a positive negative. It's got to add to positive 2. Okay. 1 and 15, that's negative 14. 2 is a decimal, 3 and 5. Okay, that adds a negative 2, just flip the signs, and negative positive. A is 1x to the second, so we know how that's going to shake out. So negative 3, positive 5, and then x times x, and you put the 1 in front. Okay. Now, those are going to stay the same. You wouldn't be able to divide. Take the 1's off the front of the x's. So x minus 3x plus 5. Now, you have 2 factors in the denominator. Here you had 1, so set the 2 factors equal to 0. And there's going to be 2 of what I think are vertical asymptotes. So 3 and negative 5. Now, do those stay as asymptotes, or does one or both of them become wholes? Well, I can cross out the x plus 5, okay? So now I have y equals 1, and then just x minus 3. You need to put a 1 on top. So x minus 3 is still there, so I keep that one, but the x minus 5 vanishes, and it now becomes a whole, okay? All right. Now, simplify the expression. X to the second power plus 7x plus 12 over x second minus 9. So there's 3 things you think about when you're simplifying, okay? First, you got to put that has 3 terms, gets a parentheses. That has 2, gets a parentheses. It's only 1 term, you don't put it in parentheses, okay? So we take the x to the second plus 7x plus 12 and try to rewrite it in factored form, the 2 parentheses. So that's 3 terms, so that would be GCF and the T-table. GCF's 1 on that. 1 times 12 is 12, positive, so it's a match. That match has to add to positive 7. So 1 and 12, that's negative 13. 2 and 6, it's negative 8. 12 divided by 3 is 4. There's your negative 7, so you make them plus and plus, okay? Because you have to get positive 7. Okay, a equals 1x to the second. So I put in the positive 3, the positive 4. So I go x, and then I apply the 1's in the front, okay? Now you can take the 1's off, well, you can divide by 1, but that's about the only thing. Then the 1's come off the front, and then I have the quantity x plus 3 times the quantity x plus 4. So I replace this with this. Cross it out, and that's replaced with x plus 3 times x plus 4. Okay, x to the second power minus 9. So that's 2 terms, so it's going to be GCF DOPS. No negative, there's no x, no negative, 1 and 9's 1, okay? DOPS, well, you got the minus, take the stupid 1 off. If there's a 1, but if there's a 4 there, you go 2x, 2x. and then 9 is 3 times 3. Okay, so it's x 3, 3. So again, replace this with these two quantities, x plus 3 times x minus 3. Okay, so get it out of there. Now, out of all the parentheses factors, I have x plus 3, x plus 3. These remain, okay, in my answer. This is my answer down here on the bottom. Now, this is for outer factors. I don't have any outer factors, okay? I just have these two, so that's a no-go. X plus 4 over x minus 3. Okay, problem number 6. Now, parenthesize first, okay? That's 3 terms. That's 1 term, don't put it in parentheses, okay? It's 2 terms, that's 3 terms. Now, multiplication, we don't need a common denominator. We're just going to extend the line and perform the same thing, okay? There's just more than 2 expressions. Now, this outer factor we just bring over. It's on top. Now you need to factor the 2x to the second plus the 5x minus the 3. So that's a trinomial, so it'll be GCF and the table. Okay, GCF's 1, so no. 2 times negative 3 is negative 6, so it's a mismatch. Positive, negative, and it's got to add to the middle, which is positive 5. 6 divided by 1 is 6. That's negative 5, so that's the right factor pairing. You just need to make it into positive 5. So positive 6, negative 1. Now your A is 2x to the second. So x times x, then 2 and 2. Now 2 and 1 can only be divided by 1, which would keep it the same, but the 2 and the 6 are divisible by 2, and they need to be divided by 2. Because at the end of a factoring process, the numbers in front of the x, 2 times 1, should be the x second. Okay? You take that 1 off, and it becomes just x plus 3. So I replace this guy on top. It has to be on top. 2x minus 1 times x plus 3. Now, x is second plus 4x, okay? That's a binomial. There's 2 terms, so it'd be GCF and DOPS, okay? X on the end, yes. Negative in front, nope. 1 and 4 is 1, so then you divide by 1x. So that's 1. X second divided by x has a remainder of x, and then 4, and then x is a dead wipeout. Okay, so we need to take that 1x down here, take the 1 off the front. I'm getting it from here. Now cross it off, okay? Now this has a plus. It can't be a dot, so I bring that down and get the 1 off the x. So you're placing this expression here with x and the quantity x plus 4. Replace this with this. Okay, 2x second plus 7x minus 4. So 3 terms. So that is GCF and the t-chart. 1 would be the GCF. ABC that. 2 times negative 4 is negative 8. So that's a mismatch. It's a positive times a negative. It's got to add to positive 7. 1 and 8. There's your negative 7. You got to make it into positive 7. So positive 8, negative 1. Still got a mismatch. A equals 2x to the second. So you put in your negative 1, your positive 8. Then x times x. Put the 2's in front. Now 2 and 1 are not divided. That would stay 2x minus 1, which is okay because the 2 and the 8 reduced by 2, 1x plus 4. 2x times 2 times 1 is 2, and that's what's in front of x second. Negative 1 times 4 is negative 4, and that's your C. take the 1 off, and you replace this expression with 2x minus 1 times x plus 4. Replace this with this. So this x came over, this trinomial was replaced with these two product parentheses, and this was replaced with this was replaced with this. Now 2x minus 1, see ya. And that's about it, okay? These can't cancel, they're both on the bottom, so it's not going to fly. So you have 3 remaining parentheses in your answer. Now, outer factors. Well, I got an x over an x. That's a dead wipeout. Now, you can put a 1 on top if you want, but really, if you already have some, you want to put the 1, put it. I don't care. Really, if you already have something there, you don't need it. Okay, now we're adding the fractions. You cannot be going over here now adding. See that adding sign? That means we need a common denominator. You can put CD if you want. This is how to find a common denominator. First, you need to put parentheses if there's more than one term. That's got 2, that has 2, 3, and 2. Now you're going to extend your fraction line. There's no equals. You're not solving for x. Your answer is the fraction that you're going to get. So you can't just cross out the bottoms like you can if there's an equal sign. Now the tops I do not need to factor, even if they are more than one term. Okay, you should not factor the tops. You're wasting time. Okay. Now on bottom, okay, those need to be put in factored form if we expect to find the common denominator. So we put the expression x second plus 2x minus 3. So that's 3 terms. So that would be GCF and the T table. GCF's 1. 1 times negative 3 is negative 3, so that's a mismatch. Positive, negative, it's got to add to positive 2. Okay? 3 divided by 1 is 3. That adds to negative 2. Flip them. Positive, negative. So A is 1x to the second power. Put your negative 1 plus your 3. X seconds, x times x. Okay, 1's your leading coefficient. 1, 1. Now those don't divide down because you'd just be dividing by 1. Okay, in the G, as far as what a common factor is. That's out. Take the 1's off the front, and we replace this with x minus 1, x plus 3. Now over here we have x plus 3, but you can't do much with that. That's a prime expression because the GCF would just be 1. And would that be a difference of perfect squares? I don't think that's even possible because it's not even a difference. It's a sum. It's a positive. It's a plus sign. Okay? So, prime. Take the 1 off the front, and that stays x plus 3. Now you're set for your common denominators. So you got x minus 1, you got x plus 3, these are parentheses, quantity factors, and then x plus 3 again. So x minus 1, I got 1 and 0. Remember, you don't count the top. So I need to get them so they have 1. So this has the 1. This is the one that needs an x minus 1 factor put in the top and bottom. X plus 3, 1, 1. Okay, that's good. You can check that. Now, you can't get rid of the bottoms because there's no equals. When you can't get rid of the bottoms, you just go down here, circle one of your bottoms, and fill it in. X plus 3, x minus 1. Now, to figure out what the top is, okay, now we can add across. So we put a plus sign, and we put a quantity on that side and a quantity on this side. Now this quantity is already set. It's x to the second minus 1. Put a 1 in front. To find this quantity up here, you're going to need to do the FOIL method. Okay, so 1x times 1x, 1x times negative 1, 1 times 1x, and 1 times negative 1. So it's 1x second That's negative 1x, that's positive 1x, and that's negative 1. So you have x to the second, x, and the constant. So x seconds the 1. X's we're not going to have because when I add these it's 0, okay? Then negative 1. Okay, so put that in there. 1x to the second minus negative 1. Now, plus you don't distribute, okay? You have x second and a constant, x second and a constant. So it's just x seconds being combined and constants, not x's. There are no x's. X second to constant. So that's second. 1 plus 1 is going to be 2, and then negative 1 plus negative 1 is negative 2. So put that on top. Wrap it up. Now, if I wanted to be a jerk, I'd make you do a GCF DOPS on that because you would be able to cross out further, but I will not. Okay, number 8. Same thing, addition. You need your common denominator to add fractions. I don't care what kind of fractions they are. Now, 2 terms on top, 2 terms on top, 2 terms on bottom, 2 terms on bottom. Now the tops, I don't care. You should not be factoring the tops. Only factor the bottoms. Okay? Leave the tops the way they are. Okay, so x second plus 4x. And then x minus 1. But the bottoms need to be factored because it's all about coming out with a common denominator. So x minus 2 is on bottom. Do you really think that's going to be able to be factored? I mean, GCF and DOPS. 1's a GCF, and that you have a minus. The 1 can be removed off the front of the x. X isn't to the second power, so that's a no. So that's a prime expression. Okay, so you keep it as x minus 2. Okay, x to the second minus 4. That's 2 terms. So GCF and DOPS. Okay, no, 1's a GCF, okay? You don't need the 1. X is to the second power, so that's x times itself. And 4 is 2 times itself. So x, 2, 2, okay? Okay, so you're replacing this with this. We could factor. We need to replace this expression right here with the x plus 2. The x minus 2. So common denominator, you got x minus 2 and x plus 2 and then x minus 2 again. So x minus 2, I got 1 and 1, so I'm good there. Okay, x plus 2, 0 and 1. So you get them both so they have 1. So x plus 2, x plus 2. Now you can't cross out the bottoms because there's not an equation, there's no equals, so you just circle one of these. X plus 2, x minus 2. And then you figure out what comes out from the top. Okay? So put that plus sign, now you can combine the tops because you found a common denominator. So this quantity is for the first fraction and this quantity is for the second. Now the first fraction I'll need to do some foiling. Okay? So I'll be taking 1x second times 1x. 1x is second times 2. 4x times 1x. And 4x times 2. One times 1 is 1. X second times x is x to the third. And then that would be 2 with x second. X times x is x second, 4 times 1 is 4. Then you're going to have x with 8. So I have x third, x second, and x, and then no constant. So x third, you got 1, 2 plus 4 is 6, and then 8. So that's your first quantity. Simplified, I multiplied that. So 1x to the third plus 6x to the second plus 8x. Now in the second quantity there's no multiplication, it's just 1x x minus 1, put the 1 there. Now you're adding. So I have x third, x second, x constant. So I start with x third. I have x second term. I have x terms, and I have the constant. So x third, you got 1. X second, we got 6, and that's it. Now the x's, we got an 8 and a 1, so that combines to make 9. And then for constants, you don't have any in here. You just have the negative 1 here. Okay, that's what you put on top now. 1x third plus 6x to the second plus 9x minus 1. Okay, now the central division problem. 3 plus 2 over x over 1 over 2 plus 1 over x. So that's your central division line. So you set up a division problem down here, okay? But you got to add on top, add on bottoms. So 3 plus 3 over x, and then 1/2 plus 1 over x. So again, to add, you need the common denominator, okay? So I don't need to put anything in parentheses, 1 term, 1 term, 1 term. So I just extend my lines, 3 over x. So the only thing you have in it as a denominator is x, okay? You have 0 and 1. So you need them both so they have 1. So x times x. Now that the common denominator is set, you can put x, put your plus sign. You don't really have to do much with the plus because 3 times x is 3x, and then 3. No, you can't add anymore. Put that in parentheses. So that's your dividend, okay? Dividend's what comes before the division sign. Okay, then I do the same thing here. 1/2 plus 1 over x, okay? So, need your common denominator. So I got 1 term. I don't need any parentheses yet, okay? You got a 2 and an x now. Okay, 2, 1 and 0. So get them both so they have a 2. I don't care if it's in front or behind. X, you have 0 and 1. Okay, so get them both so they have 1 single x. Okay, this one has the 1, this one needs it. So times x times x. Now, we have the common denominator set. 2 times x is 2x. Now, put your plus sign. Now, 1 times x is 1x. 1 times 2 is 2. You can't add any more. Put the parentheses, and you have the quantity 1x plus 2 over 2x. Now, make it multiplication. You keep the first the way it is, and you flip the second to 2x over 1x plus 2. Okay. Now, nothing, you don't have to do any factoring, okay? The parentheses don't cancel. Now, if you can factor the parentheses, well, fine. They don't have to be, though, okay, with this division crap. So put your 3x plus 3. Now, if you wanted to factor out a 3 in that one, you could, okay? It doesn't really matter. But those parentheses will remain in the final answer. Now, what about the outsides, the outer factors? Well, you got 2x over x. Well, these x's are both to the first power. The 2 is going to stay in the answer, and then these would just cancel out. Okay. Okay, now we're solving the equation. So we have x over 2 equals x plus 1 over 4. Okay, now you are solving for x. You're finding what it equals. Now, here's the equation. We just have one ratio on each side, so we don't need to do a common denominator. We just use our cross multiplication or cross products. Because A times B is equal to C times D. So I make an equals with 2 products of parentheses with the times on each side. Okay, so A is x, B is 4. That's A times B. That's equals C times D. So C is x plus 1. You can put the 1 there. And then D is 2. Now over here, it's just going to be 1x times 4. I mean, you just multiply them. You don't need to really distribute. If you have an x, 1 times 4 is 4. Now over here with the plus, we need to distribute the 2 to the 1 and the 2 to the 2x. So 1x times 2 is 2x, and 1 times 2 is 2. Now, I have x only, so that is linear properties, okay? There's one answer. Linear properties, if you have x on both sides, you take out the smaller one. You don't clear one whole side. That's factoring properties. So 2x equals 2. Then I divide by 2 and I get 1. Okay, 1's your solution. Okay, number 11. 3 over x plus 1 equals 1 over x second minus 1. So again, the whole idea is to find what value x would be to make this equation true. Okay, so a, b, c, d. You're doing the cross multiplication, cross products. So equals parentheses times parentheses, parentheses times parentheses. So I'm taking a times b. Remember, the diagonal products are equal, c times d. So a is 3 and d is x to the second minus 1. You might want a 1 there for later. And c is 1, d is x plus 1. Okay, over here you have to distribute your 3 to 1x to the second and 3 to negative 1. So, plus negative if you want. 3 times 1 is 3, but we still have that x to the second. 3 times negative 1 is negative 3. On the other side, you got a positive. 1 times 1x is 1x. 1 times 1 is 1. Now, look through that equation. Now you have x to the second with x. So now you're using the factoring properties. Okay? So there's going to be two answers, I think. So factoring properties, you need to clear one side. Clear the side with the smaller x to the second. Well, since that has a 3x second, this doesn't have x second. This would be my side to clear. So I would subtract 1x, and that has to hang because it doesn't have. Then minus 1, that can go with the negative 3. So now you're clear, you're at 0. You have x second, then your x, then your constant. So 3 is my x second, then negative 1 is my x, negative 3 minus 1 is negative 4, equals 0. Didn't line that up very well. Okay, 3 terms, GCF and T-chart. Okay, 1's a GCF, ABC. 3 times negative 4 is negative 12, so it's a mismatch. It is a positive times a negative. It has to add to negative 1. Okay. 1 and 12, that's negative 11. 12 divided by 2 is 6, that's negative 4. 12 divided by 3 is 4, and there's your negative 1. So your A is 3x to the second power, positive 3, negative 4. Then x times x, and you put your 3 in front, okay? Now these are identical numbers, so you would divide by 3 to get 1x plus 1. Take the 1 off the front of the x. You don't do anything with that 3, okay? 3 and 4, now that would just be 3x minus 4. So then to get the two answers, I just line those up on the line, x plus 1 times 3x minus 4, and I do my F1, F2. Use your zero product property. So the x plus 1 could equal 0, or 3x minus 4 could equal 0. So I subtract 1, and I get negative 1. Then over here I add 4 to each side, that's 4. 3 times x equals 4. 4 divided by 3 is not a good looking decimal. So second PRB it, be 1 1/3. You could also put 4 over 3. Okay, number 12. 1 over x plus 1 over 3 equals 6 over x second. Now you have to solve for x, but you can't use a cross multiplication. You have 3 ratios, including a plus on one of the sides. So you have to. That's when you have to go to your common denominator. You want to get all 3 denominators to match. Now you need any parentheses? I don't think you do. because that's one term, one term, one term, one term, one term, and x to the second's one term as well. So everything, no parentheses needed. So if I don't have any parentheses on the bottom, I don't have to factor anything. Okay, you can't rewrite one term. So common denominator, you have outer x, you have 3, and you have another x second is an outer x. It's just 2 of them. So 1, 0, 2. So we need everything to have 2. So this already has one outer x. If I times by another one, I'll have 2. Remember, x second means 2 outer x's. This one needs 2 as well. It doesn't have any, so times x times x times x times x. Now everything has 2. That's at 2x's, 2x's, 2x's. We are set. Now 3, 0, 1, 0. So this one and this one need a factor of 3. I don't care if it's brought in the front or behind. It doesn't matter. Okay. Now with the equals, we get rid of the denominators because remember, I don't make a fraction. I want to find out what x equals. Now I drop my equals. I'm going to make a quantity for that, and then I put my plus sign down, then a quantity and a quantity. So 3 times 1 is 3 times x is 3x. 1 times x is 1x, and then 1x times x is 1x to the second power. Then over here, 3 times 6 is 18. Okay, so now take out the parentheses. You get 18. Now you don't times, that is a plus. You have x and x to the second. Well, x to the second comes first in the order, in the standard order, and then x. So you don't really add anything because you just got 1x second and 3x. Okay, now look through the equation. Well, we have x second with x. That's the factoring properties. So that would be 2 answers. So you have to make one side equal to 0. Clear that side. 1x second, then I don't have an x second here. That's the side to clear. Minus 18, and that would just hang. Okay. So we have x to the second, x, the constant, equals 0. So I have 1, 3, negative 18. So it's 3 terms. So that would be GCF, and then your t-table. No x, no negative. 1's a GCF, ABC. 1 times negative 18 is negative 18, so that is a mismatch. Okay. It's got to add to positive 3. So 1 and 18, no. 18 divided by 2 is 9, that's negative 7. 18 divided by 3 is 6. Well, now that makes negative 3, so stop. You just got to switch to positive 6, negative 3. A is 1x to the second. Okay. Okay, so x times x. Put the 1's in front of the x's. Those can't divide down, they just stay the same. Okay, now bring those over. X minus 3 times x plus 6, and that is what we use to get our 2 answers, the factors, factor 1, factor 2. Okay, so x minus 3 could equal 0, x plus 6 could equal 0, so I add 3, and I get 3, and then I subtract the 6, and I get negative 6. Okay, number 13. 1 over x plus x over x plus 2 equals 1. So again, we can't use a common denominator because I have adding between the we can't use the cross multiplication method because we have the plus between 2 of the ratios. So we have to get a common denominator. So parentheses, no, 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 yes, because that's a plus sign. So that's 2 terms. And then that's empty. Don't put a 1 there. So on top, you got 1x and 1. Nothing in parentheses. Now bottoms, ask yourself, can you factor the expression x plus 2? I mean, this one just goes down. X plus 2 is 2 terms, so that would be GCF and DOPS. GCF's 1. Plus is not a dot, so that's a prime expression. Okay, so you keep that in the form it's in. Now we can figure out our common denominator. So we have an outer x and a parentheses of x plus 2, and then this is empty, not for long, it's not going to be. Outer x, 1. This has 0. You don't count the top and you don't count the bottom because that's not outer, that's inner parentheses, it's an inner x. So 0 and 0. Okay, these two need an outer x, so put that in front of the parentheses. Right there. X plus 2, I have 0, 1, and 0. So you have to bring in the x plus 2 to the first and the last. Okay, now with the equals, you get rid of the denominators, and now you drop the equals, and you figure out what the heck's going on as far as what I have for x solutions. Okay, parentheses plus parentheses equals parentheses. Now, this is easy. 1x and 2. It's 1x plus 2. This is easy. X times x is x to the second power. Place the 1 in front. Now this, you take the x times the 1, which is 1x, and then you take 1x times 1x and 1x times 2. So that's x to the second and then 1. This is x with 2. Okay, now simplify. This side, we got 1x second plus 2x. Now the side with the 2, remember the plus sign means you're not multiplying, not foiling, you're adding like terms. You have x, a constant, and x to the second. So x to the second, then the x, then the constant. So x second 1, x is 1, the constant's 2, so nothing really gets combined. Now when I look through that, I'm like, okay, I've got x second with x, so I'm using the factoring properties, and I got to find two answers. But you know how I said clear the side with the smaller x to the second? What happens if you have an x second and x second and they're equal? Well, then x second goes bye-bye. See ya. Gone. So now I have 1x plus 2 equals 2x. So if I see that those x seconds are the exact same value, cancel them because it's no longer factoring properties, it's linear properties because now you have x only, okay? So I just got one answer. So I would subtract the smaller x. 2 would equal 1x, and you can divide by 1 if you want, but it's just 2. Okay, now story problems.